In this example, we want to find the simplified form of the difference quotient for the function x to the third. So our difference quotient is f of x plus h minus f of x all over h. And remember, we do not want h to equal 0, so h cannot equal 0. So here we go. The algebra, it might get a little messy depending on your algebra skills. So x plus h to the third is what we want to do. We want to plug in x plus h wherever we see x in our function. So we're going to have, let's just write it out first, and then we'll start to do some manipulation here. So x plus h to the third. So I'm replacing x with x plus h minus our f of x, which is just going to be x to the third, because that is our f of x function, all over h. Now I want to expand out x plus h to the third. So that's going to be x plus h times x plus h times x plus h. That's probably just the safest route to go. There are ways of multiplying that out, but starting off, probably just safe to go with this route. After you do a lot of these examples, you'll start to remember maybe the simplified form of x to the third. After you do this a couple times, you'll see a lot of the same x squared, x to the third kind of pop up a lot, so you'll get used to it. So if we just want to multiply this out, I'm going to do the first one. So x times x is x squared plus xh, and then we have plus xh plus h squared. And this is all still need to be multiplied by x plus h, but let's go ahead and just simplify this first. X squared plus xh plus xh is 2xh. 1 plus 1 is 2, so 2xh plus h squared. And it's still all multiplied by this third x plus h here. So that was just this multiplied together. So let's go ahead and do the last set here. So I have to multiply x squared times x squared times h, 2xh times x, 2xh times h, and then try and make this not look super messy, h squared times x, h times h. So we have to do all of those terms. So first one, x squared times x is x to the third. X squared times h is x squared h. 2xh times x is 2x squared h. 2xh times h is 2xh squared. 2xh times x is 2x squared h, and then 2xh times h is 2xh squared. And then last one, h squared times x is xh squared. H squared times h to the third. Yeah, a little messy, not super clean. Now we have to do some combining of the like terms. I have x to the third, nothing's going to combine with that, so I'm going to have x to the third here. I do have an x squared h. You got to be careful with the exponents here. Make sure you're not just like glancing and grabbing the wrong like terms. Like for example, x squared h is not a like term with xh squared. The x squared has to be the x has to be the squared term. So x squared h and 2x squared h are like terms. I don't see any more x squared h, so this is going to be 3x squared h. And then I do have 2xh squared and xh squared, x to the first, h squared. So that's going to be 3xh squared plus, and then we have that lonely h to the third. Whew. Wow, yeah. Not the worst, but definitely not super pleasant there. So x to the third plus 3x squared h plus 3xh squared plus h to the third. And like I said, you'll see this a lot, so maybe just make a note when you're doing problems and just say, like, all right, here's the expansion of x to the third. So that way you don't have to keep doing it over and over again, but it is good practice to just keep doing it over and over again, but not extremely necessary. I would just probably make a note somewhere and just say, all right, here it is. So we do it all over again. And then we want to subtract off x to the third, so minus x to the third. So this whole statement right here, this was just that. All of this was just to expand the x plus h to the third. And we still have that minus x to the third. You don't want to forget about that. Extremely important. All over h. Let's take a breath, and now we have to do some more simplifying. X to the third right here, minus x to the third, those are like terms. Boom, bam, gone. 3x squared h plus no other like term with that. So 3x squared h, and as I talked about, make sure you're noticing x squared, x to the first, not like terms. So it's 3x squared h, and then I have 3xh squared, nothing there. So 3xh squared, and then I have that h to the third again, all over h. Where do we go from here? What do we do? I have all of these h's, I have this h. What we want to think about now is doing some factoring. Factor out some term that we can factor out. I see a 3, I see a 3, I do not have a 3 here. So I can't factor out a constant. I have an x squared, I have an x, I do not have any x's here. Can't factor out an x. But I do have h squared, h to the third. Nice. I could factor out an h. So I'm going to go ahead and do that. I'm going to factor out an h, leaving me with 3x squared plus 3x h, because I took out the h, and I took out an h from h squared, so I'm left with an h. And then I still have h squared in that term. And that is all over h. Bonus, h over h, boom, gone. So all we're left with here is 3x squared plus 3xh plus h squared. The h's cancel out, so then that's what we're left with. And the note we made earlier, h is not equal to 0 right from the start because h was in the denominator there, so something to keep in mind. But there it is, the simplified form of the difference quotient for the x to the third.